Okay, now let's look at a couple of problems that are present value annuity problems. Now, you really need to make sure you work the review because when I tell you we're in present value annuity problems, it kind of gives it away. But when these problems are mixed together, that's when it's difficult to determine which is which. But here we're dealing with present value annuity. So it says, how much money must you deposit now? So in other words, how much should you put in the bank to now that earns 6% interest compounded quarterly in order to be able to withdraw $3,000 at the end of each quarter for 2 years? Okay, now you're going to pay yourself quarterly payments. So that means we have an annuity. But here's the catch. These payments that you withdraw, these payments that you withdraw, the $3,000 payments, they're actually going to decrease the balance of that money that you deposit now. So since those payments decrease the balance, this is a present value annuity. And since we want to know how much we need to deposit now, we're looking for the present value. So we're given the payment is $3,000. We're given the rate is 6% or 0.06. We know we're compounding quarterly, so M is 4 for 2 years, so T is 2. So I would simply be 0.06 over 4 or 0.015, and N would be 8. So we want to find the present value. So let's take a look at the present value annuity formula. So that would be this formula here that I just gave you in the previous video. And so I need to plug in for payment the $3,000. For I, I'm going to go ahead and put in 0.015. Since it's a terminating decimal, I don't have to write it as a fraction, so I can just put in 0.015. And then for N, I'm going to put in 8, but remember the exponent is negative N, so it's negative 8 here. And then you divide by 0.015. So now, if I do this in a calculator, I'd have 3,000 times this expression, then divided by 0.015, and I'll get $22,457.78. So basically, I need to put in the bank now $22,457.78. But if you think about it, since I'm going to withdraw 8 payments of $3,000, that means I'm actually going to get $24,000 out of this deal, even though I only deposited $22,457.78. So the difference in the $24,000 that I'm going to withdraw and the $22,457.78 that I deposited has to be the interest that this account earns. Okay. Now, another example would be when you're if you're calculating the payment on a car loan or a house loan, then you can use the present value annuity formula. But if you're calculating the payment, then you would use the payment formula. So in this example, you borrow $90,000 at 4.5% annual interest rate to purchase a house. And then it says the family agrees to pay the loan off by making monthly payments over a 15-year period. Now, a 15-year period is probably not the most common. I think the most common payoff period for a home is 30, but if you pay it off in 15 years, that actually saves you a lot of interest. So I'm going to do this for 15 years. How much should the monthly payment be in order to pay off the debt in 15 years? Okay, now you're making, actually that should say monthly payments, so quarterly payments, not quarterly, but you're making monthly payments, so therefore this is an annuity, and those monthly payments will decrease the balance, so that would be a present value annuity since they decrease the balance. Now, you're actually trying to solve for the monthly payment. So, we know the present value is $90,000. We know the rate in decimals 0.045. We know money is compounded monthly because in this chapter, if I tell you we're making monthly payments, we'll also have monthly compounding. So we have monthly compounding for 15 years. T is 15. So I would be 0.045 over 12, and then N would be 12 times a year for 15 years. So that would be 180 payments. Okay, so we want to find the actual payment. So we'll use this formula, and then we'll put in 90,000 for the present value. I'll go ahead and put this in as a fraction, 0.045 over 12 for I. So, and also I have to put it in the denominator, 1 plus 0.045 over 12. And then remember, N was 180, so we put minus 180 here for the exponent. Now remember, if you put a negative, TI calculators don't let you use the subtraction key for a negative exponent. You actually have to use the negative key. So anyway, this would be I over 1 minus 1 plus I to the negative N. And you can see that your monthly payment would be $688.49. Now, make sure you understand that that payment is only for principal and interest. Actually, what happens is when you actually buy a home, many times they will also roll in to your monthly payment. They'll also roll in your monthly insurance payment and your monthly tax payment to be paid on your houses. So you know, this payment might be a couple $100 more, based on, depending on how much you owe each month for taxes and insurance. But the $688.49 that's the amount of money that you're paying. That's called P&I, principal and interest. So that's the amount you're paying for principal and interest, is $688.49. So again, like I said, don't worry about the taxes and insurance, but I'm just letting you know that, so that someday if you buy a home, you don't come back to me griping and saying, I thought you said the payment was going to be $688.49. No, they'll probably roll into that payment your taxes and insurance for the house. So that's the basic formulas for the present value annuity. In the next video, I'll show you some other things, as well as how to create an amortization schedule